In this segment, I will discuss constructs and measures. In designing a research study, we have to consider both how we will measure our constructs and the details of the study design, including what type of study, such as experimental lab design, a survey study, or a quasi-experimental field study. Where the study will be conducted, who the participants will be, and what the procedure will include. In this lecture, I will discuss measurement of our constructs, and in the next lecture, I will address study design. First, I will go over definitions and explain what constructs and operational definitions are. Secondly, I will talk about how we turn constructs into measures and discuss some basic ideas and concerns we have in this process, such as reliability and validity. Constructs are the abstract things we are interested in. These can be things like employee performance, education, emotional labor, turnover and retention, and employee happiness. There are usually many choices on how to measure constructs. Even something as seemingly concrete as turnover is not so simple when you go to measure it. Is it the number of employees who leave in a year? We can measure it as the ratio of the number of employees who leave in a year to the total number of employees. Is it only people who leave voluntarily, or do we want to include people who have been fired? If it's voluntary, do you want to distinguish between those who had to leave for reasons under their control and those that left for reasons not under their control, such as health issues or a family move out of state? How you measure your constructs can have an effect on the outcome of the study. So we need to put our constructs into a measurable form. We call this measurable form an operational definition. It is defining the variable in terms of how it is measured. An example of this could be employee happiness, measuring this in terms of a response on an item asking, to what extent have you felt happy in the last hour, on a scale of 1, not at all, to 5, extremely. Another option could be the number of times a person smiles in a 10-minute period. This would then get coded by some observer, either directly or via a videotape that had been taken. So let's go back to our self-regulation hypothesis. Emotional control during work, or emotional labor, is predicted to have a negative relationship with dietary restraint. So doing a lot of emotional labor will lead to a lower ability to restrain oneself. For emotional labor, we may choose a self-report measure of showing happiness when the person is angry. The actual measure will be more specific, such as asking the person, have you, in the last hour, to what extent have you had to suppress feeling angry and act as if you were happy? Alternatively, we could ask people to give ratings on several emotions in terms of both how they have felt and in terms of emotions that they have had to display. From those ratings, we could calculate the extent of showing happiness when being angry. For dietary restraint, we also have many options. We have chosen eating a birthday cake in the lounge, but there are many others, such as the amount of candy eaten at work during the day, eating poorly when getting home from work, or perhaps something more personally meaningful in asking people about items they are trying to avoid, since different people are trying to avoid different things. As you can imagine, the latter is going to be much more difficult to get to without tailoring we will need to tailor the study to that person or ask open-ended questions, which become more labor-intensive to score. Also take note that your measure may be worded backwards from how your hypothesis was constructed. In this case, dietary restraint, which takes self-control, is measured by an activity that lacks self-control, so eating the birthday cake, in which case we need to reverse our predicted direction. All measures have their flaws. We can question whether these measures are really getting at the things we are interested in. Two ways of assessing how well our measures work are to look at the reliability and the validity of them. I will discuss these concepts and various types of each in the next few slides. So when talking about evaluating measures, we want to look at two things. Reliability, which is the extent to which a measure consistently gives the same answer or score, and validity, the extent to which a measure correctly assesses what it's expected to measure. So the extent to which it gets at the construct we're interested in. I want to mention here also that although it seems that this is getting into the nitty-gritty of study design, and you may not find it interesting, it is extremely important, especially for something like employee selection. The assessments we use to determine an applicant's credentials must be both valid and reliable. If they're not, we're going to have a tough time using those assessment scores in order to select the best employee. And sometimes we can even get into legal trouble if it turns out that a measure is also having an adverse impact on protected groups. In addition to this, I personally find it fascinating just to contemplate the challenge of turning something abstract into something concrete in terms of the operational definition. So let's talk about evaluating measures in terms of reliability. Now remember, reliability is the degree to which a measure is free of random error and is consistent in the scores that it assigns. So if a thermometer says 30 degrees every time it's at a given temperature, it may be reliable, but this might have nothing to do with the right temperature. Perhaps the given temperature at which it shows 30 degrees is really 50 degrees. So every time it is 50 degrees, it shows 30 degrees. And every time it is 60 degrees, perhaps it shows 35 degrees. In this case, it is consistent, it is reliable. It is not giving us the correct temperature. Reliability indexes the correlation between two readings. There are several different ways to look at this consistency. One of these ways is to take the same test twice. This is what we call test-retest reliability. It looks at the relationship between scores at two different points in time. Those who score high should score high again the second time. The rank order should stay the same. So people who were at the top of the scoring list should remain at the top, and those who are in the middle remain in the middle, and those at the bottom remain in the bottom. Another way to look at consistency is to use what we call equivalent forms. This requires making two equivalent tests. Professors often do this for exams. There will be test A and test B, for example. This is also done with many standardized tests. Not everyone gets the same questions, but the content that is assessed is the same, and it's created to be at the same level of difficulty. It is very hard to make two genuinely equivalent tests, however, it is very often useful for test security reasons. A third way to measure consistency of a measure is to look at the items within the measure to see if they are all giving answers that are about the same. We call this internal consistency. It is the extent to which items measure the same thing. It is assessed by looking at the relationship among all the items. If the responses to items are highly correlated, the test is said to be measuring one thing and to be internally consistent. A fourth and last type of reliability is inter-rater reliability. This is the extent to which two raters will come up with the same score. Many assessment exercises use raters to assess performance on the exercise. These assessments are not always objective and can lead to discrepancies. For example, when conducting interviews, it is important that all members of a selection committee see the job candidate in the same way. They can do this by using a standard form and what is called a structured interview. This involves asking all candidates the same questions and having a scoring form to indicate the different levels of performance on those questions. We use inter-rater reliability to measure agreement among raters. If raters do not agree, we conclude that the behavior was not reliably observed. A measure may be reliable, but it still might not be valid. Remember, validity is the extent to which the instrument is measuring what we are trying to measure. It is measuring our construct of interest. So the thermometer that says 30 every time it is actually 50 degrees is not valid, even though it is reliable. Validity is not a function of the measure itself, but what we use it for. While validity is essentially one thing, we use several indices to measure it. Ideally, we should consider all of these. I'm going to discuss three broad types of validity. First, criterion-related validity tells us how well a measure predicts some criterion or outcome. It is probably the most practically significant of the three forms of validity, particularly in terms of prediction. It also is one we use most often and is the easiest to defend. We try to show that people who score high on the predictor also score high on the criterion or outcome we're interested in. In some cases, in the case of employee selection, this would be job performance on the job. We can use a correlation or regression model to show this relationship. Criterion-related validity can either be assessed by looking at measures of the predictor and outcome taken at the same time, which is what we call concurrent validity. So we may use current employees and measure both the predictor of interest and the outcome we are interested in. Or we can measure criterion-related validity using what we call predictive validity. In this, we look at the predictor at time 1 and the outcome at time 2. So this may be in terms of measuring applicants when they are applying for a job and recording performance once they are in the job in the future. A second type of validity is content validity. We want to measure all of the content of what we are hoping to measure and not additional things. We can't always measure content validity since it's conceptual. Sometimes expressed as a proportion, such as a test, how much a test covers. So for example, a test might cover 80% of an identified content area. This is often used for knowledge exams, such as police knowledge necessary for entry officers. Sometimes we use subject matter experts to help us determine the extent to which a test is content valid. A third type of validity is construct-related validity. This tells us how well a measure reflects its underlying construct. Constructs, remember, are the theoretical concepts we're interested in. We use these to explain behaviors. And although constructs are not tangible, we have to use concrete tests to assess them. So in order to assess construct validity, we use two different methods. One is convergent validity. This compares the measure to other measures of the same construct. They should be strongly related. Discriminant or divergent validity compares the measure to measures of unrelated constructs. These should not be related. So, for example, a test of physical strength should not be related to a test of leadership. So let's go over these types of validity. Criterion-related validity is related to an outcome that we're interested in. For example, a test we give applicants may be related to performance, and we want to show that it is related. Content-related validity is the extent to which the measure contains all of and only what it is intended to measure. And construct-related validity is asking whether the assessment is measuring what it is supposed to be measuring. As you can see, content and construct-related validities are very closely related. So reliability is a necessary component of validity, but it is not a sufficient condition for validity. As we discussed, something can be reliable, but not be valid. But a measure has a hard time being valid if it is not reliable. So take a moment to look at the ASVAB webpage. We discussed this measure previously. There is a page specifically set up to discuss the validity of the ASVAB test. And remember, Project A was the big project meant to gather information on the validity of this test. So here, there's a discussion of content validity, construct validity, and criterion-related validity of the test. Take some time and read through this. A confounding variable is one that is intertwined with a predictor and affects our outcome variable, making interpretation of the results a challenge or impossible. Let's look at a couple examples. Method to teach. Fred Rogers wanted to test a new sing-along method to teach math to fourth graders. He used I Love to Multiply to the tune of God Bless America. He used the sing-along method in his first period class. His sixth period students continued solving math problems with the old method. At the end of the term, Mr. Rogers found that the first period class scored significantly lower than the sixth period class on a mathematics achievement test. He concluded that his sing-along method was a total failure. Was he justified in coming to this conclusion? If we look at how he assigned students to the sing-along method or the old method, we can see that he confounded this with which class period he was using. So the first period class all got the sing-along method. The sixth period class all got the old method. We can imagine there may be several differences in the class periods, either simply because it is the time of the day, and perhaps people in the sixth period class are more awake in order to do their test, or in terms of the students that are in the class and other things that might happen within the class period. Let's take another example. Scenario 2. An airport administrator investigated the attention span of air traffic controllers to determine how many incoming flights the average controller could coordinate at the same time. Each randomly selected controller was tested without his or her knowledge by a computer program which fed false flight information to a computer terminal. The controller first received information from one plane, and by the end of the hour was coordinating the flight patterns of 10 planes simultaneously. The administrator analyzed the errors collected by the computer program. The analysis revealed that 6 was the maximum number of planes a controller could handle without making potentially fatal errors. Also, no errors occurred when only 1 to 3 planes were incoming. He concluded that a controller should never coordinate more than 6 incoming flights. Was the administrator justified in coming to this conclusion about how many flights an air traffic controller could attend to at once? Again, we have a confounding variable. Again, we have a confounding variable. The way the study was designed, the controller first received information from one plane. By the end of the hour was coordinating 10 planes. So at the beginning of the study, when the controller is more rested and more able to attend easily, there were only 1 or 2 planes. As the time went on and the controller got more tired, as time went on and the controller got more fatigued and tired, there were more planes. Perhaps controllers needed a break around 40 or 45 minutes, regardless of how many planes they were currently attending to. And that would have been about the time that they got 6 or 7 planes. This idea of confounding variables is often wound up in the study design. In the next lecture, I will discuss study designs and how to avoid these confounding variables. Please go through the interactive activity